Bismillahirrahmanirrahim. Assalamu alaikum dear students. I, Ms. Satya Naseem, on behalf of Garrison Academy Senior Campus, welcome you all to APSEC's online support program. This is week 1, day 3 of our chemistry lesson for class first year. We will continue with unit number 1, stoichiometry, and the objective of today's lesson are: you will be able to discuss the concept of percentage composition with examples. You will be able to determine the percentage composition of different compounds. You will be able to understand the concept of limiting reactant and the reactant present in X's. Students, before going to the main topic, let's have a brief recap of the previous topic. In sample problem number 1.2, part 3, you have moles of iron, and moles of iron is equal to 5.32 moles, and you have to convert the moles of iron into grams. The formula, the equation that you will use is your desired quantity is equal to given quantity multiplied by the conversion factor. What is the given quantity? 5.32 moles of iron is your given quantity. Now, how you will guess the conversion factor? In this case, the conversion factor is not written from a balanced chemical equation. Why? Because you don't have any balanced chemical equation, because only one substance is involved, and that is iron. And just what you have to do is you have to convert the moles into grams, and no balanced chemical equation is there for this part. So in this case, the conversion factor is written from the knowledge that you have about iron. And one thing is same, and that is your desired quantity is written in the numerator, and your desired quantity is the mass of iron in grams, and your given quantity is written in the denominator, and your given quantity is moles of iron. Now, what knowledge you have about iron is that you know that 1 mole of iron contains how many grams of iron? 1 mole of iron contains 55.9 grams of iron. So in this way you can guess the conversion factor. Now you will cancel the same unit, that is mole of iron and mole of iron, and you will get the answer in grams. This is one way to solve this question. The other way is you can use the formula mass is equal to moles multiplied by molar mass. Moles are 5.32 moles multiplied by molar mass of iron is 55.9 gram. So this is the second way to calculate the mass of iron from the given moles of iron. The third method is you will write, we know that since 1 mole of iron contains how many grams of iron? 55.9 grams of iron. So 5.32 moles of iron contains how many grams of iron? 55.9 divided by 1 multiplied by 5.32. So you will get the answer in grams. So these are the three ways to calculate the mass of iron from the given moles of iron. But the most important method is the conversion factor method. Yes, friends, so let's continue with the topic. Today we will study topic number 1.3, percentage composition. By the term percentage composition, we mean that we calculate the percentage of each element present in a compound. For example, magnesium oxide is an ionic compound, and in order to find out the percentage composition of magnesium oxide, we calculate the percentage of magnesium and percentage of oxygen present in this compound. For example, the percentage of magnesium is 60.3% and the percentage of oxygen is 39.7%. So in simple words, we can say that by the term percentage composition, we mean we calculate the amount of elements present in a compound. And in case of magnesium oxide, we calculate the amount of magnesium and oxygen present in magnesium oxide. Percentage composition is also known as the percentage by mass. Why? Because we are calculating the mass of, for example, in this ionic compound, we are calculating the mass of magnesium, and we are calculating the mass of oxygen, and we are calculating these amounts in terms of percentage. We are expressing the amounts in terms of percentage. Percentage composition is also known as mass percent. Actually, we are calculating the mass of the elements present, but we are expressing the mass in terms of percentage. One more important thing to note is that when these percentages are added together, when the percentages of all the elements present in a compound are added together, the answer comes out to be 100. Students, let's discuss the definition. The relative amount of each element in a compound are called the percentage composition. Means when we calculate the amount of each element present in a compound, this calculation comes under the topic percentage composition. For example, the percentage composition by mass in magnesium oxide is as follows. In magnesium oxide, the percentage of magnesium is 60.3% and the percentage of oxygen is 39.7%, and this is the percentage composition by mass. It means 60.3% magnesium is present in magnesium oxide, or we can say that the mass of magnesium in magnesium oxide in terms of percentage is 60.3, and the mass of oxygen in magnesium oxide is 39.7 in terms of percentage. Important note, the sum of percentages of all elements in a substance must be equal to 100. Like in case of magnesium oxide, 60.3 plus 39.7 is equal to 100. Before students discussing the next topic, that is determination of percentage composition, how we can determine the percentage composition, let's study this topic with the help of example, and then we will come back to this topic again. Yes friends, so how can we calculate the percentage composition of magnesium oxide? First of all, we have to calculate the molar mass of magnesium oxide. The molar mass of magnesium oxide is, the mass of magnesium is 24 plus the mass of oxygen is 16, so 40 gram per mole is the molar mass of magnesium oxide. Now, how to calculate the percentage of each element, that is magnesium and oxygen, present in this magnesium oxide? The formula used is, you have to write the mass of element. For example, you are finding out the mass of magnesium in 1 mole of magnesium oxide, so you will write the mass of magnesium in the numerator and molar mass of the compound in the denominator, and you will multiply it by 100. So how to solve this question? How to calculate the percentage of element? What is the formula used to calculate the percentage of element? The formula used is percentage of an element is equal to mass of element in 1 mole of a compound divided by molar mass of the compound multiplied by 100. So in order to calculate the percentage of magnesium, what is the mass of magnesium in 1 mole of magnesium oxide? The mass of magnesium is 24. And what is the molar mass of magnesium oxide? We have calculated the molar mass, it's 40 multiplied by 100. So the percentage of magnesium in magnesium oxide is 60%. So what is the percentage of oxygen in magnesium oxide? The mass of oxygen in 1 mole of magnesium oxide is 16 gram. The molar mass of magnesium oxide is 40 gram per mole multiplied by 100. So the percentage of oxygen by mass is 40%. So this is the way to calculate the percentage composition of magnesium oxide. So let's go to the previous topic. How to determine the percentage composition? First of all, you have to calculate the molar mass of a compound. Second point, calculate the percentage of each element in 1 mole of the compound, as we have calculated the percentage of magnesium and the percentage of oxygen. This is done by dividing the mass of each element in 1 mole of a compound by the molar mass multiplied by 100. Mass of an element divided by the molar mass multiplied by 100. So this is the way to determine the percentage composition. Yes friends, so let's calculate the percentage composition of glucose. This is the review question. It is a very important question. How you will calculate the percentage composition of glucose? This is the formula of glucose, and you will calculate the percentage of carbon, hydrogen and oxygen present in glucose. Or we can say, in other words, we will calculate the mass percent of glucose. So first of all, let's calculate the molar mass of glucose. The molar mass of glucose is equal to 12. 12 is the mass of carbon and there are 6 carbon atoms. So 12 multiplied by 6 plus 1. 1 is the mass of hydrogen atom multiplied by 12. There are 12 hydrogen atoms. So 1 multiplied by 12 plus 16 is the mass of oxygen atom and there are 6 oxygen atoms. So 16 multiplied by 6. When you will add these quantities, the answer will be 180 gram per mole. So this is the molar mass of glucose. Now, in order to calculate the percentage of an element, the formula will be percentage of an element will be mass of element, that is the mass of carbon, the mass of hydrogen and mass of oxygen in 1 mole of compound divided by molar mass of the compound multiplied by 100. So let's calculate the percentage of carbon in glucose. The mass of carbon is 72, that is 12 multiplied by 6, that is equal to 72 divided by 180, which is the molar mass of glucose multiplied by 100. So the percentage of carbon in glucose is 40%. Percentage of hydrogen is equal to 12 because the mass of 12 hydrogen atom is 12 gram divided by 180 multiplied by 100. So the percentage of hydrogen is 6.67%. The percentage of oxygen is equal to 96. 96, from where did you get 96? Because 16 is the mass of one oxygen atom and there are 6 oxygen atoms. So 16 multiplied by 6 is equal to 96 divided by 180 multiplied by 100. So the percentage of oxygen in glucose is 53.33%. Students, when you will add these percentages together, that is 40 plus 6.67 plus 53.33, the answer will be 100%. I hope, students, this topic is clear to you. Let's discuss the second topic, that is topic 1.4, excess and limiting reactant, page number 12. Let's discuss a very simple daily life example. Students, for example, these ingredients are given to you. Then how many sandwiches you can make from these ingredients? Let's see the ingredients first. There are 3 kebabs, there are 4 buns, there are 6 cheese slices, and there are 7 tomato slices. 2 tomatoes for each bun. So 1 tomato slice will be left behind. 1 cheese slice for each bun. So 3 cheese slices will be left behind. 3 buns will be used for making the sandwiches. 4th bun will be left unused. So these are the ingredients which are left unused. If we consider this as a chemical reaction, then we can consider the ingredients as reactants, and we can say that these are the reactants which are present in excess after the chemical reaction. These are the reactants which are not consumed. These are the reactants which are present in excess. So we call these reactants as the reactants present in excess. Now, why only 3 sandwiches are made in this cooking process? Because we have only 3 kebabs. It means kebabs limit the sandwiches. Kebabs control the amount of sandwiches. If we consider this as a chemical reaction, then the kebab is the limiting reactant. Why? Because it limits the amount of sandwiches. It controls the amount of sandwiches. There are only 3 kebabs present, so only 3 sandwiches can be made. If we consider this as a chemical reaction, then The limiting reactant is the reactant which controls the amount of products that is formed. It limits the amount of products that is formed. The limiting reactant produces least amount of product. Very less product is formed from the limiting reactant. The limiting reactant is the reactant which is consumed earlier, and it controls the amount of products. It gives very less products. It gives the least products. I hope students, the concept of limiting reactant and the reactants present in excess is clear to you. Actually, the limiting reactants are the reactants which are taken in lesser amount and they are expensive. The limiting reactants are consumed earlier and they limit the amount of products that is formed. They produces the least amount of products, and the reactants present in excess are the reactants which are left unused or unreacted when the reaction is complete. And the reactants in excess are always taken in a greater amount and they are comparatively cheaper. Yes friends, so let's discuss the excess and limiting reactant in more detail. For example, before the reaction we have 10 moles of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 7 moles of oxygen. 1, 2, 3, 4, 5, 6 and 7. So we have two reactants. One is hydrogen and the other one is oxygen. Now, when the chemical reaction takes place, then water molecules are produced. So, how many water molecules will be produced from 10 moles of hydrogen? As we know that in the water molecules, 2 hydrogen atoms are present and 1 oxygen atom is present. So, from 10 moles of hydrogen, how many water molecules will be produced? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only 10 water molecules will be produced from 10 moles of hydrogen. Then, how many water molecules will be produced from 7 moles of oxygen? As we know that 1 molecule of water contains only 1 oxygen atom. So, how many water molecules will be formed from 7 moles of oxygen atom? The water molecules formed will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 water molecules will be formed from 7 moles of oxygen. Now students, which reactant gives the less number of water molecules? Hydrogen or oxygen? Hydrogen, 10 moles of hydrogen produces 10 water molecules, and 7 moles of oxygen produces 14 water molecules. So, which reactant produces the less number of water molecules? It is hydrogen, because it produces only 10 water molecules. So this reactant is the limiting reactant, and oxygen produces 14 water molecules. So oxygen is the reactant present in excess. Yes friends, so 10 water molecules will be produced, and how many oxygen will be consumed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 moles of oxygen will be consumed in the formation of water molecules, and 2 moles of oxygen will be left behind. So oxygen is the reactant present in excess. No hydrogen molecule is present after the reaction. So the hydrogen molecule is the limiting reactant. Yes friends, I hope the concept is clear to you. So let's discuss the definition of limiting reactant. Limiting reactant is the reactant that is consumed completely in a chemical reaction. Limiting reactant is not left behind after the completion of the reaction. It is completely consumed, or in other words, we can say that the reactant which produces the least number of moles of the products in a chemical reaction. The reactant which produces very less products in a chemical reaction is the limiting reactant. Then let's discuss the reactant in excess. The reactant left unused or unreacted after the completion of a reaction. Means after the completion of a chemical reaction, the reactant which is left behind, the reactant which is not completely consumed is the reactant present in excess. Before discussing the topic, identification of a limiting reactant means how to identify a limiting reactant in a chemical reaction. Let's discuss this topic with the help of an example, and then we will come back to this topic. So, the example is, let 10 moles of hydrogen and 7 moles of oxygen were reacted to produce water. The limiting reactant can be determined as follows. The general reaction is 2 moles of hydrogen combines with 1 mole of oxygen to produce 2 moles of water. So let's identify the limiting reactant. First of all, let's see how many moles of water are produced from 2 moles of hydrogen. Part number 1. If 2 moles of hydrogen are used, then 2 moles of water are produced according to a balanced chemical equation. Then, if 10 moles of hydrogen are used, that is according to the question, then how many moles of water are produced? Obviously, how to calculate this value? 2 divided by 2 multiplied by 10, so the answer will be 10 moles of water. So, 10 moles of hydrogen produces 10 moles of water. Let's discuss the second reactant, that if part number 2, if 1 mole of oxygen is used, then according to a balanced chemical equation 2 moles of water are produced, and according to the question, if 7 moles of oxygen are used, then how many moles of water are produced? 2 divided by 1 multiplied by 7, so the answer will be 14 moles of water will be produced from 7 moles of oxygen. So if we compare both the reactants, hydrogen produces less number of water molecules as compared to oxygen, which produces greater number of water molecules. So hydrogen is the limiting reactant. Since hydrogen produces least amount of product, therefore it is the limiting reactant. So in actual practice, after the completion of a reaction, how many water molecules will be produced? Only 10 water molecules will be produced. Hence, moles of water produced will be 10 moles of water. So students, how to identify a limiting reactant in a reaction? The first step is, if the reactant is given in grams, you have to convert these grams into moles. So the first step is, number of moles of each reactant is calculated. If the reactant is given in grams, then you have to convert the grams into moles. Then point number 2, using balanced chemical equation, amount of product from each reactant is calculated, as we have calculated the amount of water produced from hydrogen and the amount of water produced from oxygen. Point number 3, the reactant which gives least amount of product is the limiting reactant, as we have discussed in the example that hydrogen produces only 10 moles of water. So it is the limiting reactant because oxygen produces greater number of water molecules, that is 14. I hope students this topic is clear to you. Students, let's solve sample problem number 1.5. 200 grams of potassium dichromate was reacted with 200 grams of concentrated sulfuric acid. We have 200 grams of potassium dichromate and 200 grams of sulfuric acid. So what you have to calculate? You have to calculate the mass of oxygen produced. You have to calculate the mass of oxygen produced and mass of the reactant left unreacted, means mass of the reactant present in excess.